So there are three types of energy that we're going to focus on in AP Physics. The first one is kinetic energy, and so I'm going to focus on that one for this video. So kinetic energy, if you saw it in regular physics, it would have been Ke. This is how much energy something has because it is moving. And there are two different kinds of kinetic energy that we're going to be learning about. There's translational kinetic energy, which is 1/2 times your mass times your velocity squared. And then there's rotational kinetic energy, which is very similar, but instead of mass, we're going to have moment of inertia, and instead of velocity, we will have angular velocity. Um, for this unit, we're going to only be dealing with translational kinetic energy, but just looking forward into the future, we will eventually have rotational kinetic energy as well. So the amount of translational kinetic energy something has depends both on mass and velocity. So this is the equation that you're going to want to make sure that you know, memorize, and or write down somewhere so it's easily accessible. And it is on your equation sheet. Kinetic energy is unique in that it is a scalar quantity, which means it does not matter which direction you're moving. I could be going forward with 5 joules of kinetic energy, or I could be going backwards with 5 joules of kinetic energy, and both of them are going to be considered to be positive kinetic energy. So the direction really does not matter. Um, in a collision, for example, in a car crash, your kinetic energy is dissipated in a variety of different forms. Um, you could warm up the car, you could warm up the roadway, there could be friction, the car could get smashed up, there's going to be some sound, etc., etc. So in this problem, the green M&M is going to go twice as fast as the yellow M&M, and I want you to think about which one is going to have more kinetic energy and how much more kinetic energy is it going to have. Go ahead and pause this video and do it. All right, so the first thing I'm going to do is go ahead and plug in the numbers into the kinetic energy equation. And I'm just going to put a 1 for everything, and I'll notice that then my kinetic energy is 1. And then what I'm going to do is I'm going to plug in for the green one, because it's going twice as fast, I'm going to plug in a velocity of 2, but I'm going to keep everything else, all these other constants, as a 1. So that means my kinetic energy then for the green one is going to be 4. But because the yellow one is like my baseline, that's the one that was just going normal speed, I'm going to put in a 1 for everything, and I'll notice that the kinetic energy is 1. That means that my kinetic energy for the green one is going to be 4 times more than for the yellow one. So what this means is that if your green one has 4 times as much kinetic energy because you drove twice as fast, then that means that you're going to have more damage if you are in a car accident. So if you are in a car accident and you're going twice as fast, you're going to have 4 times more energy that you need to dissipate, which means that your car is going to get way more smashed up. In other words, 4 times the kinetic energy, 4 times the damage.